Hello, and welcome to the second grab bag video for ME123. Today, we're going to cover some additional tools in SolidWorks, including text, wrap, and scale for part files, flexible components, belt or chain mates, and assembly features for assemblies, and the SolidWorks Toolbox. These are all handy tools that exist within the software. Let's take a look at how they work. Okay, let's go through them in order. Here, I have a small cylinder, and we're going to engrave some text onto it. We're going to begin by opening a new sketch here on this top surface, and then we can draw in a line that we want our text to follow. In this case, we're going to start easy with a midpoint line centered on the origin, extending out horizontally. Now that we have that drawn, we can left-click on it to turn it into a construction line. From here, we can go up to the Text tool up on the Sketch tab of the ribbon. Choose the line to fill in the curves box, and then we can type in the text that we would like. If you don't like the default size or font, you can uncheck the Use Document Font box down here, and then select the Font button. These options allow us to use any of the fonts that are installed on the computer, so you can pick the one that speaks to you and set its style and height. In our case, let's use the Impact font and set it to 5 millimeters tall. Now that we have our font set, we can manipulate the letter scaling, the letter spacing, the formatting, and bolding and italicizing. Once you're done with all of those settings, you can hit the green checkbox, and we can finish adjusting our text by modifying the sketch line that it is based off of. In order to edit text that you've created, you can double-click on the text within the sketch, and that brings you back to the modification box that we were working with earlier. Of course, you can also use curved lines instead of just straight ones. If we right-click on the curves box and select Clear Selections, then we can left-click on this outer edge here, and we can see that the text is now going to be following that circular arc instead of the construction line that we created earlier. One thing to be very careful of with curves is you want to make sure that the letters are not overlapping like they are here. In cases like these, you may want to increase the spacing in order to minimize these overlaps. Once you have your text set up the way you like, you can hit the green checkbox, and from here we can use this like we would use any other sketch, though there is one exception. To our standard rules that I would like to make clear. Text within sketches can be notoriously difficult to fully define. Because of this, it is our other exception to our definition rule. Do your best, but it's okay to leave it underdefined if it's not cooperating. When we're all done and finished with our sketch, we can then use this to create additional revolves or extrudes like we have earlier. In this case, let's go over to the Features tab and select Revolve Boss Base, where we can see it's going to use the profiles produced by our text and the center line that we drew along the middle in order to create some new geometry. Well, that's pretty much as incomprehensible as I would have expected. Moving on. Next up is Wrap. The Wrap tool allows you to engrave or emboss geometry on non-flat surfaces. This can be very handy with creating particularly tricky shapes. Let's punch an ellipse out of the side of our cylinder. I'm going to begin by making a tangent reference plane off of the surface of our cylinder, and then we'll set it so that it's perpendicular with our front face. Now that we have that, we can open up a new sketch on this brand new reference plane to go about drawing our ellipse. Let's center it on the origin, and we'll make it so that it is 70 units wide from endpoint to endpoint, and 30 units tall. Add some horizontal relations to go about fully defining it to keep it from spinning, and then we can exit our sketch, go over to Features, and select Wrap. Now, Wrap is one of the few features in SolidWorks that can be either a positive feature or a negative feature. We can choose Emboss, which adds material, Deboss, which removes material, or Scribe, which cuts the surface along the given sketch geometry. Let's use this as Deboss for now. Continuing down, we have our Wrap method. If you're wrapping onto a cylinder, you're going to want to pick the analytical option, and in pretty much every other case, you're going to want to select Spline Surface. If one option gets angry at you, try swapping it to the other. Next up, we have our wrap parameters. From here, you need to choose the sketch that we're going to be wrapping, the surface that we want it to wrap onto, in this case this one here, and then we're going to need to choose our depth. Let's set this to 5. Now that we have that set, we'll hit our green checkbox, and we can see what it looks like. Not bad. One thing to note is that even though the sketch originally went beyond the bounds of our cylinder, the wrap feature was able to function properly. As the name implies, it takes the profile that we give it, treats it like a piece of fabric, and wraps it around that surface, instead of just projecting the geometry like the other tools that we've covered before. Last up for our part tools, Scale. This one is just going to change the scale of your entire model. It lives up here under Insert, Features, Scale. From here we can choose the point that we want it to be scaled about. In this case we can choose from the centroid, the origin, or a specific coordinate system. And then we can choose whether or not we want our scaling to be uniform, which increases or decreases the size equally across every axis, or if we uncheck that box, we can scale it differently so that it's stretched or compressed in one of the 3 axes. Last, you choose the scaling parameter. Let's set this to 2 to make it twice as large in all directions, and hit our green checkbox. From here, we can go up to our Evaluate tab, and if we measure the diameter of the bottom edge of our cylinder, we can see that this is now 100 millimeters, where it used to be 50. Alright, that's it for the new part features. Let's move to assemblies, starting with flexible components. As the name implies, flexible components are parts that can bend or flex as the assembly moves. Now, not every part can be made flexible. The process requires the part to be modeled in such a way that its features and sketches are reliant upon other parts in the assembly. Unfortunately, this does mean that at least one sketch must be left underdefined. Let's make a flexible spring, since those tend to show up in models fairly frequently. So, the helix curve is the usual way that we make springs, but it doesn't lend itself particularly well to making flexible components, so we're going to have to come up with a different method. Let's use an offset sweep that's twisted around a vertical line. Alright, so we're going to begin by drawing ourselves a sweep path. This is just going to be a vertical line, so we'll start it at the origin and have it going up an unspecified amount. As mentioned earlier, we're going to need to have a portion of this part be left underdefined so that we can link it with the rest of the assembly. Whenever the height of our shock absorber changes, the length of the spring is going to have to change, so we're going to leave this endpoint of our sweep path underdefined. Now, our next sketch is also going to be on the front plane, though it needs to be in a separate sketch from the sweep path. I'm going to draw in a circle. We'll set its center point to be horizontal with the origin. We'll set its diameter to be 10 units wide, and then we'll set the midpoint of our circle to be 50 units away from the sweep path. Now that we have our sketches done, we can pop over to the Features tab and select Swept Boss Base, where we're going to choose the circle to be our sketch profile and the edge to be our sweep path. From here, we're going to go under the Options tab and select Profile Twist and set it to Specified Twist Value. We're going to set the twist control to revolutions and set it so it makes 6 full revolutions as it goes along the path. That looks good to me. We'll hit our green checkbox, and now we can see that if we go in and we modify the length of our sweep path from this length to this length, when we exit the sketch, the spring gets stretched accordingly. Lastly, I want to give us some flat surfaces to make the spring with. So we're going to open up the front plane for a new sketch once more and draw in a rectangle. Set it to go from here to here. Reveal the sweep path so that we can see a bit better of what's going on. Connect the center point of the top edge to the top of the sweep path, and repeat the process for the bottom edge and the origin. And finally use a tangent relation with this bottom circle to snap it so that the rectangle is just the right size. Now that we have this sketch fully defined, we'll pop over to Features, select Extruded Cut, set it to Through All Both, check Flip Side to Cut, and we are golden. We'll save our part as Spring Demo and pop it into our assembly. In order to go about defining this, we can mate this central profile so that it is concentric with the pin checkbox. We'll mate the bottom surface so that this surface here matches up with this face on the cap checkbox. But on the other side of the spring, we're going to need to do something a little bit different. Instead of going about mating surfaces, we're going to go into the spring component itself and open up the sweep path. And here, we're going to set this endpoint, the one we left underdefined earlier, so that it is instead coincident with the bottom edge of the other cap. This makes it so that the spring sweep path is now defined based off of the location of the top plate. When we exit our component, we can see that the spring has been stretched to go that entire distance. And if we were to drop this plate down and rebuild the model, the spring size would change accordingly. Finally, to set it so that this does live updates, we're going to need to right-click on the spring component and select Make Part Flexible. From here, we're going to choose the edge that we used as our defining edge, in this case this one here, and select our green checkbox. Now, whenever we move the cap, our spring will be automatically stretched or compressed to match its current location. This even functions within animations, allowing you to make smooth videos of your assembly. In this example, we only set it so that the length of the line would change with the assembly updates, but you can also have it so that other aspects of the sketch are modified. I want to make a cable that stretches between these two holes on this hinge, and make it so that as the hinge moves, the cable bends and is updated to take the new geometry into consideration. In this case, we're going to open up a new part and start a sketch on our front plane to create our sweep path. I'm going to begin by creating a center line that starts at our origin and goes out horizontal, and another center line that starts on the origin and goes up at an angle. We're going to leave this angle to be the bit that is underdefined. Next up, I'm going to create a spline with 2 control points, one at the end of this construction line and the other at the end of that one. You can hit the Escape key to stop the spline, and when we left click on it, we can see that we now have these control handles. You can set the handle so that it is perpendicular with the construction lines that we created earlier, and we'll repeat the process on the other side as well. And this is going to ensure that the cable will always come straight out of the hinges. We can then use our smart dimension to decide the length of the overall spline. In this case, let's set it to 120 units. And then we can set the construction lines to be equal. This leaves us with a couple of things underdefined, as we can stretch and contract the endpoints of the construction lines that we've created, and we can modify the angles that they make with one another. We can wrap this up by popping over to the Features tab, selecting Swept Boss Base, setting ourselves to Circular Profile, and choosing our spline as our sweep path. We'll leave our diameter at 10 millimeters, hit our green checkbox, and we have a flexible component. To make life a little bit easier, I'm going to add some little tabs on the ends of this sweep. There we go. That'll make it fit into the holes of the hinge much better. There we go. I've taken the liberty of importing our tube into the pre-created hinge assembly. At this point, we can start adding some mates. I'm going to connect it so that this edge down here matches up with this edge on the inside of the hinge. And from here, we're going to need to edit the sketch to make it so that the edge is going to match up with the center point of this arc. So we'll hit the drop down next to our component, go down to Sweep, right-click, Edit our sketch. And we can take this endpoint here and this edge there and set those to be midpointed. Now that we have that settled, we can hit Edit Component once more to exit the editing menu, and we can see that the entire model has been updated to take the new shape into account. Once again, we're going to right-click on the tube, select Make Part Flexible, choose this edge as our reference entity, checkbox. Now as we move this hinge, we can see that the tube is automatically modified to take the new geometry into consideration. Okay, next up is the belt mate. This is a useful tool for whenever you've got belts or chains that go through your assembly. Mechanically, it acts as several gear mates stapled together, and it allows for the rotation of one component to drive the rotation of several other components. It also has the added benefit of calculating the required length of the belt for you. Let's use it in this pulley-covered pegboard to see how it works. To start, the belt lives here, under Assembly Features. To start, we're going to need to select the components that we want our belt to wrap around. It's often easiest if you can have sketch circles set up in each one of the components to act as a reference for the pulleys. I've added these sketches into the part files for us to use here. As we go around our model to loop the belt, we can see that it's going to show us the path that the belt takes across the pulleys. Once you're finished adding all of your pulleys, you can change the direction that the belt approaches that pulley from by selecting that sketch or that entity in this option here and selecting the Flip Belt Side option, which pops it around to the other orientation. We can also change the order that the belt takes these pulleys into consideration by using these arrows here to move down and move up for each individual sketch. We can also swap the orientation by left-clicking on the gray arrows that show up next to each one of our pulleys. Continuing down, we can check this box to set a belt thickness, which isn't going to modify anything within the model itself, but it will tell us different lengths that might be required. Let's set this to 2. Additionally, we can change the plane that the belt is going to be represented on by selecting this box here and choosing another surface. So we can pop it up to this, we can pop it down to there, or we can deselect to leave it as it was. Once you're finished, you can hit our green checkbox, and you can see that when we spin one of these pulleys, all of the others spin to match according to the rules that we set with our belt. Okay, next up is Assembly Features. I want to add a crank onto this large pulley to make it easier to spin. However, I don't want to modify the part file itself to add the mounting holes for it. Assembly Features allow us to modify a specific instance of a part, so that there's only going to be one of them that are affected. This also allows you to modify multiple parts simultaneously. One thing to note is that assembly features are mostly negative, so they function best while removing material, such as drilling holes or engraving patterns. They can also be dependent on several part files. So, as an example, if we insert our crank file, left-click to place it here, and then use our mates to put it into position. So let's set it up so that this and this are concentric. Left-click drag to move it out a bit further. Set the two surfaces to be coincident, so that one there and that one there. Checkbox. And then link this surface and this surface to be perpendicular. What we can then do is use the holes that our crank already has provided as templates in order to define where the holes are going to be positioned on the larger pulley. From here, we can go up to Assembly Features, select Extruded Cut, and select this surface as the one we want our sketches to be drawn on. At this point, we can use Convert Entities to select this edge here and this edge here, checkbox, and that will create our sketch for us. Now that we have our sketch drawn, we can exit the sketch, define our end conditions. Let's just set this to through all, and hit our green checkbox. Oops, that looks like it went a little too far. The holes that we'd created punched all the way through the pegboard on the back. Let's go back into our assembly feature to fix that. Similar to standard features, you can right-click and edit to modify the feature's conditions, and within here, we can choose our desired scope, or exactly which parts we would like the feature to change. It defaults to selected auto-select, but we can get more control over the specifics by selecting the green box here, right-clicking to clear selections, and then explicitly selecting the thing that we would like modified, in this case the pulley. We'll hit our green checkbox, and we can see now that the holes only go through the pulley, and they leave the backboard untouched. Lastly, we're going to cover the SolidWorks Toolbox. The Toolbox contains a lot of common, standardized components that are used in many SolidWorks assemblies, such as screws, bolts, gears, and bearings. While we're within our assembly, we're going to go over to the right-hand side and select this Design Library tab. From here, we can select the Toolbox option and choose the Add In Now button, which is going to load the plugin. At this point, we can choose the standard library that we would like to work within. Let's go ANSI metric for now. And from here, we can choose what we would like to explore. Let's start with bolts and screws, and then pick the options that make the most sense for our application. I'm going to pick socket head screws, and let's use a socket head cap screw. We can left-click drag our component from this sidebar over here into the assembly, and at this point we can go about modifying what exactly we would like our screw to look like. I'm going to modify the size to an M10. We'll set our length to about 25. That sounds like it ought to work. We can modify the drive type, in this case a hex head, but they do have some other options. We can specify thread length and thread display. I often find that schematic makes it easiest to see what it is that you're working with. And once you have all of your settings set the way that you would like, you can hit your green checkbox and it will automatically generate the component. From here, you can then left-click to place several more of these screws, and once you're finished, you can hit the escape key and begin mating them into position. At this point, you can pretty much treat the screws like any other component that you would be adding to your assembly. You can apply mates to them, you can modify them with assembly features, and you can change their color, but you never need to worry about creating any additional part files. Last note for these, if you do decide that you want to modify one of the screws, you're going to want to right-click on it in the design tree and select Edit Toolbox Component. This brings us back to the menu that we used to create the part. In addition, we can even go up to here to change fastener type and choose a different screw entirely to base our design off of. Well, that about covers everything that I had to talk about for today. I hope that you learned something useful, and as always, do play around with the options that you have available to explore these tools even further. Have a good day. We will see you again next time.